Hi folks, and welcome to another online maths tutorial from CD Masterworks Limited. So we've got another wee module from the expressions and functions unit for you today. We're going to be looking at parallel and perpendicular gradients. And we're going to split these skills up as follows. Look at parallel gradients first of all, then we'll look at perpendicular gradients, and then finally we'll finish with a wee mixture where we're going to introduce some exact values into proceedings. So first of all, parallel gradients. So here's an example of a set of parallel lines. And we should know from National 5 that parallel lines have equal gradients. That's a fact we should already know. So here's a typical higher maths question. Find the equation of the straight line which is parallel to the line with equation 2x plus 3y equals 7 and which passes through the point 1, 2. So the keywords in this question are parallel, the equation and the point. That's the relevant information for us. So what we're going to do first of all is we're going to rearrange the equation to find the gradient. So first of all we get 3y, and we do that from taking 2x from both sides. So 3y is minus 2x plus 7, and then to get y on its own we divide both of these terms by 3. So minus 2/3 x plus 7 over 3. So we've now rearranged the equation into the form y equals mx plus c. So we can quite easily read off the gradient. It's just the number next to the x, so the gradient is minus 2/3. And because our line is parallel, that means we're going to use that same gradient of minus 2/3, and we're just going to substitute that along with the point 1, 2 into y minus b. So we have y minus 2 equals minus 2/3 bracket x minus 1. And providing there's no part b where we need to have this equation in the form y equals mx plus c, we can just leave the equation as it is after the substitution. So here's 5 for you to try, and if you're working on these at home, pause the video now. Okay, you've unpaused the video, let's go over the answers. So we should have got y plus 1 equals 4 bracket x minus 3, y minus 7 equals 3/5 x minus 4, y minus 4 equals 9 over 2x plus 5, y minus 9 equals minus 1/2 x plus 2, and y plus 8 equals 7 over 6 x minus 10. Okay, so moving on to the second outcome, where we're going to be looking at perpendicular gradients. So you saw in the previous outcome an example of two parallel lines that run in the same direction. And here we have two lines which are perpendicular to each other. And as we can see here, perpendicular lines meet each other at a right angle. So the higher fact that we've got to know is that these two gradients will multiply together to give us minus 1. So if we know one of the gradients, we can calculate the other one simply by turning the first gradient upside down and changing the sign. So here's a typical higher maths question. Find the equation of the straight line which is perpendicular to the line with equation 5x plus 2y equals 3 and which passes through the point 1, 6. So again the key information is the word perpendicular, the equation and the point. So we can treat this question in exactly the same way first of all, because we're going to rearrange the equation into the form y equals mx plus c to find the gradient of the first line. So we take 5x from both sides, so we've got 2y equals minus 5x, add 3, and then we divide both of the terms by 2. So that gives us y equals minus 5 over 2x plus 3 over 2. So the gradient of our first line is minus 5 over 2, which means that our perpendicular gradient, we turn minus 5 over 2 upside down and change the sign. So this will give us positive 2 over 5. So we sub the perpendicular gradient and the point on the line into y minus b, and that gives us y minus 6 equals 2 over 5 bracket x minus 1. So here's 5 for you to try, and if you're working on these at home, pause the video now. Okay, you've unpaused the video, let's go over the answers. So y plus 3 equals minus 1/3 x minus 5, y minus 9 equals minus 4 x minus 2, y minus 4 equals minus 2 over 7 x plus 1, y minus 11 equals 3 bracket x plus 2, and y plus 1 equals minus 3/4 x minus 7. Right, so let's finish with our third outcome, the mixture with exact values. This will be a mixture of both parallel and perpendicular, so you'll have to make the decision whether to use the same gradient or to turn it upside down and change the sign. And all of these questions will be non-calculator questions. So for this section, we're going to need to know your exact values. So we're going to find the equation of the straight line which is perpendicular to the line, which makes an angle of 30 degrees with the positive direction of the x-axis and which passes through the point 2 minus 7. So again, our relevant information is perpendicular, 30 degrees, and the point 2 minus 7. So first of all, we need to find the gradient of our first line. So to calculate the gradient that a line calculate the gradient of a line when we know the angle that it makes with the positive direction of the x-axis, we just use the formula tan theta. So first of all, we've got to get the tan of 30, which is 1 over root 3. So m1 is 1 over root 3. Because it's perpendicular, to get our second gradient, we turn the 1 over root 3 upside down and change the sign. So that's going to give us minus root 3 over 1, but an easier way of writing that is minus root 3. And we use the perpendicular gradient minus root 3 and the point 2 minus 7, and we substitute into y minus b, and that gives us y plus 7, double negative there, watch out, equals minus root 3 bracket x minus 2. And we can leave it like that. So here's 5 for you to try, and if you're working on these at home, pause the video now. Okay, you've unpaused the video, let's go over the answers. So y plus 1 equals minus 1 over root 3 x minus 4. Y minus 5 equals 1 bracket x minus 3. Y plus 1 equals 1 over root 3 x minus 8. And then the trickier ones to end. Y plus 3 equals 1 bracket x plus 2. And then y minus 5 equals 1 over root 3 bracket x plus 10. And that concludes our online tutorial on parallel and perpendicular gradients. Hope you found that useful, and stay tuned for the next one. Bye for now.